Hi, welcome to How to Repair. Have you ever wondered how selector switches for ovens, cookers and many other appliances are tested to comply with the standards around the world? Well, I've got the luck today of actually being at Gottak in Spain, which is one of the world's largest selector switch manufacturer. And I've got the privilege of being allowed to work alongside Victor, who is their chief testing person in the factory. He's an engineer that tests all the selector switches to make sure they comply with the standards. Nice to meet you, Victor.
Hola, Paul.
Victor's going to be showing me not only how they are mechanically tested, but Victor's also going to be showing me how they are electrically tested in a heated environment, which simulates the oven's situation and also the cooker situation, where the actual selector switches are normally inside underneath the hob, and they are normally working in quite a warm cavity area. So Victor, when it comes to testing the actual switches, I believe there are different regulations around the world. Can you tell me what these regulations are?
There are 3 certifications: ENEC, VDE and UL.
Which is the one that matters to Europe?
All around the world.
Oh, they're all around the world, are they? Okay, thanks. And how many revolutions does the actual switch have to do to comply with the certification?
20,000 more or less.
20,000 more or less. Don't concentrate too much because I know it's difficult English to Spanish. So once the switches have passed the test, the next procedure, I believe, is the ovens. Okay, Victor has explained to me off camera, because it is very difficult for him to explain things on camera, and he's actually explained the whole testing procedure of a selector switch. Now here we have the oven, and the oven is actually connected to the selector switch, not only with a rotational system, which is on the other machine over there, it has also got the actual electrical connections connected to the actual terminals on the switch. Now what you're seeing on the screen here, and this is a Gottak switch, and I'm going to show you the difference between switches in a minute, but when the switch is first turned on, and I'm just grabbing a pen so I can show you. The reason I can't touch this screen is it's a highly calibrated touch screen, so I'm going to use the blue marker to show you. The oven is the red line. This means that the temperature of the oven is 150 degrees while the first 5,000 tests are being done. The switch has to do 10,000 tests, 5,000 under heat and 5,000 without heat after. The switch is actually started at this point, which you can see, where it drops in temperature and load is first put on the switch. As you know, the contacts at this point will be cold, but as the points open and shut, they generate heat. And here you can slowly see the heat rise, but it gets to a maintained level of somewhere in the region of about 15-degree differential between the baseline. And it continues like this all the way along while it's under load and at a constant 150 degrees. Then the oven chamber temperature is turned off and the temperature drops. Because we're not seeing any spiking on the green line or the blue line, and let me explain these to you. We have temperature probes inside the oven, which I'll show you shortly, which measure the temperature on the bridge and also the contact plates. And I'm not allowed to tell you too much information with regards to their secrets, but I can explain it to you. Basically, because the temperatures are maintaining, even with 16 amp load, this switch is not only passing its test, it's passing its test with flying colours. And now I'm going to show you, and I've got to let Victor turn the camera off a second because he's got to go into the loading procedure to show you the other switch, which is a competitor's switch on the other side. So take me through to another switch, please. One that's failed on the other oven. Okay, so here you can see a switch that was put under load and tested. And exactly the same at the beginning, and I haven't got my pen to hand. Thank you. So at the beginning here, you can see where it was started because it drops down in temperature slightly and then starts working pretty much the same as the Gottak switch, apart from there is a differential between the blue and the green, which we did not see on the Gottak switch. But at this point, we can see something has happened with the contact. And after this point, the temperature starts to rise and the green line suddenly becomes critical. Now, what I'm explaining that happens here, and I'm going to move and I can't show you too much because I'm not allowed to, but the contacts on the points will be getting worse and worse because they do not put the correct alloys in the actual contacts. Gottak uses silver contacts, which is the difference between the weak alloy contacts. And as you can see here, the heat that was generated has got to the point where the contacts fail and there's no continuity.
No continuity.
So at which point does it fail? Here, it's totally
a massive spark.
Yeah, so you've got a lot of sparks here, and at this point it was just a catastrophic failure.
Yeah.
Thank you very much for showing me that. I've had the joy of working with Victor all week, and not only have I been taken around the factory and made many videos for you with regards how Selector switches are manufactured using the robotic system, how the injection molding plant makes the actual plastics and the bakelite casings, but I've also had the use of the testing facilities here to test many different type of products, which I wanted firm proof in what I am saying. Manufacturers today are buying too many components which have built-in obsolescence in them. If a cooker is used once a day and it is used for 2 years, it has most probably had 700 cycles on the Selector switch. And Victor has actually proven on many occasions with me that there are so many Selector switches here that have failed between 700 and 1,200 cycles. And this is just sheer proof that too many manufacturers are building obsolescence by choosing the cheaper components, which works in their favor. And predominantly, this is because the accountants are running these companies instead of the technicians that used to run the companies. And I'm not going to mention any names, but some of the top brands in the world today are using inferior products because obsolescence is part of the criteria that they require. They don't want your cooker, washing machine, dishwasher to last any more than 5 years nowadays. All they care about is you, the general public, purchasing more of their equipment. And there is too much greenwashing going on with regards, I have Wi-Fi on my cooker, I have automatic cleaning on my cooker. These are all factors that are built in to guarantee obsolescence in the appliance. Anyway, I hope you enjoyed this video. There'll be many more videos going up with regards to Selector switches and the construction. Please remember to subscribe to the channel and make sure you hit the like button as well, as this really does help improve the video content on my channel. Thanks very much indeed for watching.